Yeah, good morning all. Again, it's me Ashwini, St. Joseph College of Arts and Science for Women, Ozur. So again, the same subject, but Unit 2. It's about K map, means Karnaugh map. The outlines of K map: sum of product, product of sum, multiplexer, demultiplexer, encoder, and decoder. These are the topic which we are going to see today. So first thing, it's about K-maps. In many digital circuit and practical problems, we need to find expression with minimum variables. We can minimize Boolean expression of 4 variables very easily using K-map without using any Boolean algebra theorems. So K-map can take two forms: sum of product, that is SOP, and product of sum, that is POS. So K-map will have these type of variables. First one, two variable map, and second thing, we can map three variable, and we can map four variable also. The order also they have given, and the values also they have given. And first one, it's about sum of product. It's a form of expression in Boolean algebra where various product means and terms are combined together uh, through sum R. Okay, suppose we have two for variables A and B and one output function F defined on them. Output is true when any input is true. Okay, and then SOP expression comes from the fact that two or more product are summed together. Sum means OR form. Okay, we know very well about OR gate. Yes, that is the logical idea of sum of product. Here we have example, Q equal to A dot B. Okay, actually A dot B is a multiplication, and b dot c, and then a dot 1. So this we have combined as sum. Okay, again a dot b dot c plus a dot c plus b dot c. This is also one of the example of sum of product. And product of sum is a function that computes the product of two or more numbers. The function has been used in many mathematical problems like calculating the number of combinational for a given number, finding the probability distribution, and generating random numbers. And POS comes from the fact that two or more sum are added together. That is, output from two or more OR gates are combined to the input of an AND gate. So we have the example of the product of sum, Q equal to A plus B dot B plus C dot A plus 1. Okay, actually the concept is sum is combined as product. And then next, multiplexer. Multiplexing means transmitting a large number of information units over a smaller number of channels or lines. A digital multiplexer is CLC that selects binary information from one of many input lines and direct it to a single output line. Which means multiplexer means many to one. The design: so AND gate used to represent input, one OR gate used to collect input, NOT gate as a selector to connect input to output. Yes, of course, 2 power n input. Here the circuit diagram shows about 2 power n input and one output. Okay, means number of input we can supply, but will get only one output. So that is the concept of multiplexer. So number of input 2 power n, number of select n, number of output will get 1. And the examples also they have given 4 into 1 multiplexer. Means there are 4 input lines. The selector S1 and S0, Y is the output. So the inputs are 0, 0, 1, 1, 0, 1, 0, 1. Okay, the 4 input are given to the line, then output will get only one output. E1 and T1 multiplexer and demultiplexer. E1 is the European format for digital transmission. According to the ITU-T recommendation, it consists of 32 channels. And T1 is the North American Digital Communication Carrier Standard that consists of 24 channels, which has 64 kbps bandwidth each. Then demultiplexer. A demultiplexer performs the reverse operation of your multiplexer, i.e., it receives one input and distribute it over several output. So this is the concept of demultiplexer, and the design of demultiplexer. AND gate used to represent the input, NOT gate as a selector to connect input to output. Here you can able to see the logic diagram. So data means only one input, and through the selector there are many output, 2 power n output we are going to get. Okay, the example they have given 1 into 4 demultiplexer, number of input 1, number of output 4, number of selector 2. So S1, S0, these are the selector, and then output 1 is output 0, O0, O1, O2, O3. These are the output. And next thing, it's about encoder. An encoder is a device, circuit, software program, algorithm, or person that convert information from one format or code to another. The purpose of encoder is standardization, speed, secrecy, security, or saving space by shrinking size. So design of encoder is OR gate used to design encoder. Again, it is also required 2 power n inputs into a number of outputs. The outputs will be n. And the example they have given 8 into 3 encoder. Number of inputs 8 means 2 power 3. Number of output requires 3. So input they have given as 0 to 7, and output A, B, C. Okay, so from the truth table, they have assigned according to the one, they have assigned the K-map values: A equal to 4, 5, 6, 7, B equal to summation of 2, 3, 6, 7, and C equal to 1, 3, 5, 7. According to the summation expression, they have we have formed the truth table also. Plus logical diagram also we have formed. And decoder, it's a decoder is a combinational circuit that converts binary information from n input lines to a maximum of 2 power n unique output lines. Design of decoder is AND gate used to represent input, NOT gate to connect input to output. And design example they have given design 2 into 4 decoder. So the input are A, B, and the output O1, O2, O3, O3. There are 4 lines of output. Okay, so according to the truth table, we have formed the logical diagram also. Here the value, here the expression they have we have formed A bar B, that is Q0, Q0, and O1 A bar B, and O2 A B bar, and O3 A B.